Section 3.4 covers three specific types of applications of systems: value, interest, and mixture. And I'm going to do one example of each. This first example is a value problem. An auditorium has 360 balcony seats and 1,200 main level seats. Tickets for the balcony seats cost $10 less than tickets for the main level seats. What should the prices be for each type of ticket so that the total revenue from a sellout performance will be $33,840? Now, the unknowns in this problem are the prices of the two different kinds of tickets. So we'll let X be the price for one kind of ticket and Y be the price of the other. So let's let X be the price for main level tickets, and we'll let Y represent the price for balcony tickets. Now from here, since we have two variables, we have to create two equations, and that will give us the system of equations. Once we have that system, we'll solve it using one of the methods that we've learned. Now the first thing we can come up with is we know that the tickets for the balcony seats, now that's Y, will cost $10 less than the tickets for the main level seats. So the equation would be Y equals X minus 10, because Y represents the tickets for the balcony seats, and that's $10 less than, meaning you have to take 10 away from the price for the main level tickets. Now the second equation comes from this information giving us that the sellout performance will be $33,840. So we also know how many seats for each that there are. There's 360 balcony seats and 1,200 main level seats. Now remember, each of these 1,200 main level seats is going to sell for a price of X, which will generate an amount of money represented by 1,200 times X. So 1,200 times X will be the amount of money from the main level seats. And then plus, there's going to be 360 balcony seats sold, each for a price Y, which when you multiply that together, it's 360 times Y. And then that equals the total amount of revenue, $33,840. The main idea in this second equation is to realize that you take the number sold times the price for each one, number sold times price, and add them together, and that gives you the total value. Now to solve the system, we can use any method we've learned. But here, since the first equation is solved for Y, meaning the Y is alone on the left side of the equation, the substitution method works really well. So we'll just take the X minus 10 and substitute it in place of where the Y is in the second equation. So that would give us 1,200X plus 360 times, and we need parentheses here, X minus 10 equals 33,840. So now we'll just solve for X. So we'll distribute the 360 through the parentheses. That will give us 360X minus 3,600. And then we'll combine the like terms on the same side of the equation together. So 1,200 plus 360 would be 1,560X. And we could add 3,600 to both sides of the equation. So if you add 3,600 here, it would cancel, and then add 3,600 over here. And so on the right side of the equation, we're going to get 37,440. And then we'll just divide both sides by 1,560, and it comes out to $24. Now remember, we let X be the price of the main level tickets. So that's what we just solved for. And remember, the other variable, Y, equaled X minus 10. So if we can just take our answer for X, 24, and subtract 10, that would be $14. And that would be for the balcony tickets. This next example is an interest problem. It says a person plans to invest $12,500. She will invest in two different funds. One's earning 12.7% annual interest and another 10.8% annual interest. How much should she invest in each account so that the total interest in 1 year will be $1,426? Now the two unknowns here are the amounts of money that she deposits in each of the two accounts. So we'll let X and Y represent those two unknowns. So X would be the amount of money, I'll just say amount, invested at the 12.7% interest rate. And we'll let Y be the amount invested at the 10.8% interest rate. So you just want to let X be one amount of money and Y be the other. Now, we need two equations, so we can get our system of equations, and then we'll solve it using one of the methods we know. The first thing we know is the total amount of money invested is $12,500. That means X plus Y has to add up to $12,500. Now the second equation, we're going to take each amount of money and multiply by the interest rate, and that'll tell us how much interest is made after 1 year. So in the first case, the amount of money is X. Well, we're going to multiply that times its interest rate. Now we'll write 12.7% in decimal form as 0.127. So that would become X times 0.127. Or we can just put the 0.127 first. So 0.127x. And then plus. And then we'll do the same for the Y. Y is the amount of money invested. And 0.108 would be the interest. So we'll multiply the two. So 0.108 times Y. And that second part here represents the amount of interest from the second account. And this first term is the amount of interest for the first account. If you add them together, it should add up to the total interest, which is given in this problem to be $1,426. So there's our system. And again, we can solve it using either method. Usually we'll just either use the substitution method if we can solve for X or Y, which wouldn't be too hard here. Or we could use the elimination method where we'll try to get opposites and then add the equations together. I think because of the decimals in the second equation, it's just going to be easier to use the substitution method. So I'll take this top equation and I'll solve it for X. Now it doesn't matter whether you solve it for X or Y, either one works. So X would be 12,500 minus Y. And then we'll take that answer and plug it in for X in the other equation. And that would give us 0.127 times 12,500 minus Y plus 0.108 Y equals 1426. Next we have to distribute to remove the parentheses, so this 0.127 has to be distributed through here. So that would give us 1587.5 minus 0.127y plus 0.108y equals 1426. Okay, so now to solve this, again, we'll combine the like terms on the same side of the equation. And that would give us 1587.5 minus 0.019y equals 1426. So notice here I've done the algebra to try to solve for y. I've combined the like terms and then subtracted 1587.5 from both sides and then divided both sides by negative 0.019. And the answer comes out to, for y, to equal 8,500. So that would be $8,500. And that's the amount of money invested at 10.8%. Now from a previous equation, we know that x equals 12,500 minus y. So if we substitute the answer 8,500 in for y, we can find x. And when we subtract that out, x comes out to be $4,000. And that's the amount invested at 12.7%. And so that would be our solution. This last example is called a mixture problem. And in this case, we're mixing two things together to create an end result. And in this problem, a chemist wants to mix a 10% alcohol solution together with a 20% alcohol solution to end up with a 12% alcohol solution. And the question wants to know how many cups of each must be used in order to make 5 cups of the final 12% solution. So the unknowns are the amount of the 10% and the 20% solution that we need to use. So we'll let x and y be those two amounts. So x equals the amount of the 10% solution, so it's the number of cups of the 10% solution that we need to use. And y would be similarly the number of cups of the 20% solution that need to be used. Now we're going to be mixing x cups together with y cups, and we want to end up with 5 cups. So that gives us one of our equations. X plus y equals 5. Now the second equation we find by taking the amount for each substance. In the first case it would be x, because that's the actual number of cups, and multiplying by the percentage of alcohol. So we take x, that's the number of cups for that one, and multiply by 10%. So that's 0.10x. And then we do it for the same thing for the y. We take y and multiply by that percent. So 0.20y. And that equals, and then we do it for the end result mixture as well. 5 cups is the amount we end up with, and we multiply by that percent. So 0.12 times 5. Now this first term represents the amount of pure alcohol in the first part of the substance, and the second term represents the amount of pure alcohol in the second part, and the last term represents the pure alcohol in the final end result. Now 0.12 times 5 comes out to be 0.6, so I'm going to replace that with 0.6. Now this time we're going to use the elimination method to solve this system. We could use the substitution method again, like we have in the previous two examples, but it'd be good to practice the elimination method as well. Now with the elimination method, remember, we have to get opposites in either the x terms or in the y terms, and then we add the equations together, and that that term cancels out. But before I do that, first thing I'm going to do is eliminate the decimals from this bottom equation. And I'm going to multiply everything by 10. Now when you multiply a decimal by 10, the decimal point moves 1 to the right. So that would become 1x. And this term would become 2y. And this term would be 6. So let me write those in. So we would just get 1x, so that's just x, plus 2y equals 6. It becomes nice and simple that way. And we still have our top equation, x plus y equals 5. Now if we multiply one of these equations by -1, these x's will be opposites, because then one of them will be negative x and the other one will be positive x, and that's what we want. So I'll go ahead and multiply the top equation by -1. Alright, and that would give me negative x minus y equals -5. And then we still have our second equation, which I'll put underneath, x plus 2y equals 6. And then we add the equations together vertically. Now when we do that, these x's cancel out, which is exactly what we want to have happen. And then we end up with a negative y plus 2y, so y equals 1. So that means, since y is 1, and remember we let y be the number of cups of the 20% solution, that means we need 1 cup of the 20% solution. Now also remember, x plus y has to equal 5. So if we know y is 1, we already know that x has to be 4. So x comes out to be 4, and that would be 4 cups of the 10% solution. And that's your solution, your x and your y.